Um, how was the party last night? Do you all have a lot of fun? Thanks for coming. It's early in the morning. I'm so happy that you all could come this morning. In case you're wondering what happened to my face and my eyes and bruises, this is a classic. I got into a fight with someone, one of our competitor in the booth. Long story short, he lost. If you're thinking I was really looking bad, you should see his face. So anyway, jokes apart, I was adventurous. I took a bike ride yesterday. I wasn't paying attention, and it was all my fault. I slipped and have bruises all over my right-hand side. Glad it didn't happen today, but I've survived. And I went back to the hotel, bloody, and the concierge said, "Now you are qualified to live in Amsterdam." So anyway. Thanks all for coming today. This is going to be a deep dive into Windows Azure virtual machines. In this talk, I will be covering a wide varieties of topic, really for developers as well as for IT pros, some of the prescriptive patterns for running virtual machines on Windows Azure. Quick agenda here. How many of you here attended Mark's virtual machine talk on Tuesday? Okay, a couple of you. How many of you attended? There was one more talk yesterday, Introduction to Virtual Machines. How many of you were able to attend? Good. I think it's good to have that perspective. I will be touching on some of the fundamentals as well, and then I'll go into the deeper side of things as we move into this. So a quick agenda here. How do you get started? I'll be super prescriptive in terms of making sure you walk away clearly knowing how do I get started on Windows Azure. Particularly if you're an enterprise customer who are already running virtual machines on-prem, I'll give you some patterns for it. Then I will introduce you to our API surface. If you're a developer, how could you automate manageability? How could you automate your deployments seamlessly onto Windows Azure? And I will show you a bunch of demonstrations that are not possible today through Portal, particularly authoring multiple virtual machines, scenarios such as building a huge web form for your organization. How do you standardize an IT image that's outside the supported stock images in Windows Azure? So I'll introduce that. Then I'll invite one of our partners who has worked closely with us, Karthik Ram from Scale Extreme, who's here with us today. He will demonstrate how they have taken advantage of the openness of the platform and demonstrate how cloud independent software vendors are innovating and providing value-added service, particularly around monitoring, alerts and notification, and governance on top of our platform. So this gives you a view from an ISV angle, how you can innovate on top of Windows Azure platform as well. Finally, I have a laundry list of things that the do's and don'ts, what works, what are the limitations today, where are we headed. I have a bunch of topics. If you're building a highly available virtual machine platform, what should you do? And if you're used to Windows Server running on your on-premise system, and if you're using many of the Windows Server primitives, how do you automate many things when you're running in public cloud, particularly in a Windows Server form? And then I'll have time to answer your questions. My colleague Eduardo is also here, so he will also join us in the Q&A session towards the end as well. So with that, let's get started. So how do you get started with a virtual machine? We covered it yesterday and day before yesterday extensively. Basically, Windows Azure Management Portal is primarily the best way to start your imaging session. We have a few stock images, what we call as a prescriptive templates: Windows Server, SQL Server, and 3 more from our publisher Linux partners. You start your virtual machine session from there. You can start your virtual machine session from a PowerShell as well, using the same library, or using the REST commandlets as well. The second option is you may find our stock image not so interesting to you. You will land into a virtual machine, you'll create a VM, you'll remote desktop into it, you'll find, wow, it's really vanilla, there's nothing in it, the ports are not configured, I don't have my IT standardized software installed in it, I need to now acquire all the software, this is not ready for me. So one of the ways we support imaging session is through what we call as a capture, image customization. So the idea here is that you start with the base Microsoft supplied stock image, and then you go ahead and make all the changes that you need, and then capture it and create your own playlist, so to speak, and then those playlist images or templates will show up in your gallery. We'll go through that extensively. The third option is migration from on-premise. So how many of you here use System Center on-premise? Okay, quite a few. Okay, great. So I'll dig deeper into, if you're already using System Center, what are the best practices? If you're bringing your virtual machines, VMs, what tools that Windows Azure offers, we'll go through that as well. All right, let's start with cloud provisioning. It's extremely straightforward. Let's say you're okay with the existing base images. You go to the management portal and start your imaging session from one of the stock images. Today we support Windows Server 2008 and Windows Server 2012, and a few images that we've gotten from our publishers. These are the Linux images. Eventually, this list will continue to grow, and we also currently have SQL Server image. You take one of those images, create your virtual machine from this template. When you create a new virtual machine, basically, we are making a copy into your local storage account. This is essentially backed up against the Windows Azure Blob Store, so this is why it is persistent. So I'm not going to cover the deep persistence nature because it was already deeply covered. The key point you need to remember here is that your virtual machine is persistent. Even if there's a hardware failure, you can restore this. It's triple replicated within our data center, and if you turn on geo-replication, it's replicated 6 times. So even if there's a hardware failure or anything, it is persisted against a blob store. You can restore it very, very quickly. All right, so this is a basic fundamental scenario of starting your imaging session from management portal. Let's move on to a little bit more advanced scenario. I was telling you about how do I create my own playlist, so to speak. How do I create my own IT standardized images from the base image? So basically, you create a virtual machine from one of these stock images. Then you remote desktop or do enable remote PowerShell into it, and enable the roles that you want. Particularly, if you are building a web stack, you need IIS, your application server stack, installed in it. Then you may want third-party software, security software, depending on your organizational requirements. You may need to customize and make all the changes. And after that, you basically do a sysprep, generalize the VHD, and shut it down. When you shut it down, basically what will happen is in the portal, it'll show up as a machine that's stopped its sysprep. And that from then, you can capture that image and create a friendly name for you. You can call it as a Contoso or my organizational stock image, and then it'll show up in the gallery. In the demonstration, I'll walk through that as well. Very straightforward. From then onwards, you can have a repeatable imaging session from that base image. So this way, you can standardize a consistent image for your large organization and make sure that your IT clearly understands how they baseline the software, how they manage the software, patch these images as well. The third and the most common scenario that we have heard from many of our enterprise customers is bring your own VMs. It's really important to recognize that we are an open platform. You can bring your existing workload from your on-premise to Windows Azure and bring it back to on-premise as well, the images that you're running on the cloud. So it's completely open, and we support the open VHD file format, which is already released to open specification promise, which is essentially covenant not to sue, so that any open source vendors, any industry can implement freely the VHD file format on any hypervisor, any hosting platforms as well. So the bring your own VM is extremely straightforward as well. Yes, sir. Great question. The VHD format, the question is the VHD format the currently supported VHD or the new VHDX format? It is the currently supported VHD, and we are looking into VHDX as well. In the future, we will look into that as well. We currently support Windows Server 2008. I will cover that today. The answer is no. It may or may not work. Currently, the supported image platforms of Windows Server 2008 R2 and above. There's nothing to stop us, but there's no guarantee that it's going to work. It's not covered under our SLA. But anything that runs on Hyper-V, you can pretty much bring. So couple of points to note here. I will cover that extensively a little bit later. We support two types of bring your own VM scenarios. You can bring disks, which is basically running images, running virtual machines. You can also bring sys-prepped images as well. And I think the key point I wanted to reinforce here is that the image-based deployment is the most preferred Windows Azure deployment model. And I strongly recommend you to consider that, because you don't want to be in a situation after uploading a large 30 gigs of VM to find out that it doesn't work for a certain reason because your SID or some of your network configuration is not supported in Windows Azure platform. So please remember always with the sys-prepped generalized image, that's a best practice. Image-based deployment always is guaranteed to run on Windows Azure. How do you bring your own VM? There are a bunch of tools. As I said earlier, the persistence nature is backed up against Windows Azure Page Blob. You can use your favorite storage explorer, any tools of your choice. It's basically a copy blob functionality. You can copy this VHD file into your storage account and then start your imaging session from there. So pretty much you can upload it. But we also provide a bunch of tools to accelerate your migration from on-premise, and I'll cover that shortly. So just to close on this, make sure when you are bringing your disks, make sure your paging file location is properly configured. Particularly, this is important caveat to remember when you're bringing a disk which is not sys-prepped. Time sync with the Windows Azure host environment, making sure that that is optimized. The third thing is licensing, activation. Windows Azure, your on-premise license is activated. These are a few caveats you need to remember if you're bringing a disk, which is why I keep enforcing you to bring always image-based deployment. It's extremely straightforward in terms of mobility. You can bring your own VM, copy into your own blob store, start your imaging session. You can bring it back. You can seamlessly download. It is at the end of the day in the blob store account. You can sys-prep, generalize, and bring a sys-prepped image back to on-premise, or you can bring the disk also back to on-premise. So completely open. I think we firmly believe in the concept of not locking in customers. You can move from Windows Azure to private cloud or to any of your partner cloud or to third-party clouds as well, seamlessly using this open format. All right. As I said earlier, we also distribute a bunch of tools to accelerate your migration of VMs from on-premise to public cloud. One of the tools that I wanted to highlight is also known as CS Upload, Cloud Service Upload little utility that we are shipping with the Windows Azure SDK. So if you install the Windows Azure 1.7 SDK, it comes with the utility called CS Upload. It's a command line tool that allows you to bring your images from on-premise to public cloud. What are the differences? I also said you can basically pretty much upload using any storage explorer, but the key point to remember with CS Upload are as follows. First, it does on-the-fly dynamic to fixed disk conversion. So if you already have dynamic disks, you can seamlessly use CS Upload and convert to a fixed disk. Second thing, it's multi-threaded. It's super fast. It has resume functionality as well. So in case if the network goes down or if you wanted to come back, it has a retry mechanism as well. Last but not least, it also goes and registers this image as a platform supported image or disk in Windows Azure library. The authentication for this utility is using your management certificate. So it goes an extra step by registering this image into the gallery itself. So when you go to Windows Azure Management Portal, immediately you will find this image or the disk that you're bringing from on-premise showing up right there for you to start your imaging session. Last thing many customers have asked for, which we have done in the last release, is essentially the patching support. Because we support dynamic to fixed disk conversion, let's say you have a new patch for your WebSphere Java stack in an image, you can just upload that piece of bits using this patching functionality also. Instead of uploading the large VM again, you can just patch this VM, particularly with respect to your app server or any of the stuff that you're running on the VM. So that's the difference between using CS Upload versus doing it on your own, copying into a blob account. Very straightforward. CS upload under the covers uses storage REST APIs as well. So it's basically a put blob. It basically goes into your storage account. CS upload supports two types of bring your own virtual machine scenarios. The first one is sys-prepped images. It also supports data disks as well. So let's say in typical scenario here is for a SQL server or running a large database application, you may have terabytes of data. The way you bring these to Windows Azure is basically first you create a VHD file. You convert all these data files as a VHD files on-premise, and then use CS upload to bring them as a VHD, and then mount this into the virtual machine. And you can do that totally programmatically as well. I will demonstrate that very shortly. All right. So again, for bringing your own OS disk also, it is a similar concept. It's basically put blob, and it moves it into your storage account. All right. So enough of talking. I think at this point, I think I've already covered bringing image versus disk, the pros and cons. So I'm going to dive into a quick demo right now. So let's come back to this slide shortly. So the demo, before I start, there are three demos I would be showing right now. The first one I would like to show you is, since many of you are using System Center, how do I seamlessly migrate my existing workloads, private cloud VMs, running on Windows Azure, running on your private network onto Windows Azure seamlessly? The first migration. Second, I will demonstrate CS upload, the pros and cons, and how you seamlessly upload into Windows Azure. The third thing, image customization. How do I go and capture an image, and have a repeatable experience of that? These are the three things that I will be showing. So let's get started. I will swap to my machine here. So how many of you have heard the System Center app controller, or how many of you are already using it? A few of you. Okay. So this is basically a new, I would call it as a deployment management application that's shipped as part of System Center 2012. What I'm showing you right now is a Service Pack 1 version of that, really focusing on Windows Azure infrastructure as a service functionalities. So the key point, the few key app controller benefits I wanted to call out are, first, it allows you to manage multiple cloud as well as private cloud subscriptions. So you basically go to your subscription management under the settings. You manage different types of subscriptions. You could have, currently it supports only Windows Azure and your private cloud and hypervisor. So you manage all the accounts in one centralized place. The second thing it also allows you is essentially an Active Directory-based, role-based access control, which Windows Azure doesn't have. Particularly, this is really useful for on-premise scenario. You may have a large organization where you would have support having full access to the production system, your developers having access to their binaries and bits and others, and the test team might have certain access. So you can have a very granular authorization enabled here. So as you notice here, I have a bunch of groups here: administrator group, engineering team group, and the DevOps group. There are some cases where the IT pros typically wear two hats of both managing the production cloud as well as the local. So you can manage all these things in a granular way in an access control. Once you set up your subscription key here, what App Controller does is, when you go to your virtual machines folder, it basically does an aggregation of all the virtual machines that you have access to and brings it into a single pane of glass for you. So here, as you see here, the App VM1 or the TechEd and all these virtual machines are all essentially my VMs from the public cloud. If I go to Windows Azure, these are some of the virtual machines I have. It's not clear how they distinguish. It's a beta product. They don't distinguish between a private cloud VM versus a public cloud VM with different icons. Today, at a subscription level, you do get to see the Windows Azure logo and stuff, but it's very hard to figure out which one is my local, which one is my public cloud. When you go to the cloud section, it gives a little bit of a better view of what you own in terms of subscription that you have access to. And the library is essentially your private collection. As an IT pro or as a developer, you may have access to your application code, virtual machines that you have access to. It could be a file share. It could be local templates, virtual VMM templates. All of them are in the libraries folder. What I'm going to do in this case is, in order to demonstrate the migration scenario, I already have a sysprepped on-premise line of business VM. This is essentially going back to Mark Resinovich's keynote demo on day one. He showed how to seamlessly migrate a line of business application onto Windows Azure. This is that virtual machine here, sitting here, and I have already sysprep generalized. It's a local machine right now. All I need to do is essentially migrate onto Windows Azure. Since I've already wired my Azure subscription, it automatically understands the deployment choices I have. I could deploy onto a public cloud on an extranet. I could deploy onto a private network, as well as onto Windows Azure here. In this particular case, I'm going to pick Windows Azure. I'm going to select my subscription here from Windows Azure. And immediately, App Controller understands all of the Windows Azure infrastructure as a service terminologies. And obviously, there are some inconsistencies in terms of terminologies here. Being a beta product, they haven't fixed some of the things such as hosted service, which is a sort of an old brand for what we used to call for web and worker role. Right now, we call it cloud services. So essentially, here, I get to pick existing hosted service where I can deploy this VM that I have already sysprepped on-premise, or I can create a brand new one. So in this particular case, I will create a new one. I will call it my on-prem VM1. This is my hosted service details. Let's call it on-prem VM. I think this should exist. Let's pick Western US as a deployment choice. And if it already recognizes that I already have a bunch of affinity groups, I'm not going to select any of them. I'm going to click OK here. So it's going to try to deploy this right now onto into my on-premise TechEd demo, and then from here onwards, I can seamlessly do a deployment choice where I want to deploy this, whether in a production slot or in a staging slot. Let's give a label here, and I can specify my VM size here, size of my VM. If I wanted to bring a data disk in the form of VHD that needs to be mounted onto this VM, I can select it here. In this case, I'm not going to select anything. So let's make sure we complete all of them. All right, so I'm not going to fully show you the deploy. When I click deploy, essentially what I'm trying to do is, right now, I've created a slot in the public cloud. I'm trying to bring an existing virtual machine that I've sysprepped on-premise and deploy onto Windows Azure. For the sake of time, I have already deployed this into one of this here. This is my demo domain controller is that cloud service where I brought in VM from my on-premise. And then I've also promoted it as a domain controller in the public cloud, which I will continue and show you later. So it's a very straightforward way to bring your own virtual machines from on-premise to public cloud. The other method that I wanted to, since we are in the portal, I wanted to cover is essentially two tools here. The first one is essentially the CS upload, bringing your own data files. This is a very cryptic command, but I thought I'll show you very straightforward. All you are trying to do is essentially you're uploading a data disk here, and you're passing your subscription ID, your certificate's thumbprint, and then also the destination of where you want your disk to be copied here. So this is a destination, and where the source VHD file is located. This is a simple command to upload from on-premise. Let's go ahead and run this. While it's running, I will show you another command. So let's run. So what it's trying to do is, obviously the network speed is pretty slow, so I created a 100 meg VHD file. Hopefully it should get started and start uploading very shortly. The other command that I wanted to show you is essentially bringing your own images, OS disks. from OS images as well as just from on-premise. This is again similar. You are, in this particular case, you are bringing a persistent OS image here. And you're using the same command using your subscription ID and your certificate. What it does is, after it uploads it, it goes and registers in the gallery as well. So you can immediately start your imaging session after you upload it. Let's take a look at it and see if it had uploaded. Hopefully, it should have done. OK, it's already done here. Let's go back to Windows Azure portal and go to the disk section. Right here. This is the one that we just uploaded, the SQL data disk. And similarly, you can also upload in an OS disk as well. Just as a demonstration, I thought I'll show you this. So we've talked about bring your own VHD from App Controller System Center. We've talked about this. The third option is customizing your image and creating your own IT stock image. Let's do that. Before I do that, I need to get disconnected from my corporate network. I'm going to quickly get disconnected. Being a service beta product, this app controller is not yet publicly released. So I had to connect to my on-premise server to really get access to that. So hopefully it is disconnected now. OK, good. So what I will do now is demonstrate how to do a sysprepped image. As I mentioned, it's super straightforward. If you have a running disk, running image, running instance, and you've customized it, you made all the changes, it's ready to be created as a playlist. All you need to do is remote desktop into it, go to the sysprep folder, run sysprep generalize shutdown, and it'll sysprep this image and shut it down. And after it shuts down, in the virtual machines folder, you will see this image in the stopped status. It'll show up as a stopped status. Only when it's in a stopped status, you can go and click this capture option. So if you're looking for this to enable, it lights up only when the image is sysprepped and stopped. So at that point, you can click capture and create your own playlist and give a friendly name as well. So I have already done that. As I mentioned earlier, the vanilla image that we provide you doesn't have all the bells and whistles. So for instance, in order to run a web form, I wanted to create a multi-tenanted web form on Windows Azure. In order to do that, I had to basically install IIS, Application Platform Stack, for faster web deployment, web deploy, and install many other softwares as well, particularly WordPress and other suite of tools to run a form-like environment. And then I did the same thing. I sysprepped the first image, and then I captured it. So in this particular case, I called it as my web VM. So when I go to virtual machine and from gallery, you see my images here. This is where your sysprepped captured playlist is going to show up. So when you capture an image, you can give a friendly name. It'll show up here. So I could start an imaging session from this image going forward for my repeatable usage. And I could go to PowerShell and create tens of or hundreds of virtual machines if I'm building a large farm or using this base image. I will show you that also very shortly. So I hope this gives you a tour of how to bring your own virtual machines onto Windows Azure. And I'll switch back to my deck. All right. So a few concepts here. Once you land in the virtual machine, I wanted to make sure that you understand the difference between the OS disk, data disk, and the cache as well. So by default, we give you a cache for your OS disk, and it has a read-write capability, particularly for OS. This is primarily for your page files, and for data disk, it's only read-only. The maximum capacity of an OS disk is 127 gig. This is not a limitation of Windows Azure, it's a limitation of the hypervisor. As I mentioned earlier, the data disk can be brought in the form of VHD as well. We support up to 16 terabytes of VHDs to be mounted, depending on the size of the virtual machine. You can change this cache setting on the fly using PowerShell, portal doesn't support it today. The cache setting change for the host cache, particularly for the OS disk, requires a reboot. For the data disk, it doesn't require a reboot. So if you don't see a D drive, note that this is primarily used as a cache right now. And all the mounted disks that you have for your virtual machine are mounted to E, F, and G, and so on and so forth, depending on how many virtual machines that you bring. And you can have up to 1 gig per disk for the data disk. This is a limitation of the storage blob. All right, so we already went through the demonstration of image customization, bring your own VM. Let's now switch gears in terms of provisioning. And this is an area where we are going to be innovating and expanding over time as well. But I'll tell you how provisioning works, what happens under the covers. First, as I mentioned earlier, when you do a create server or create a virtual machine, there is the base image in the platform image repository or the platform gallery. Currently, we have a few templates in the form of Windows, SQL Server, and bunch of Linux images. So when you do a create server, we basically, you can use the management portal. It uses a storage API. We create an ISO with all your provisioning details. We pretty much use a Windows setup for the provisioning here. So what essentially happens is your computer name, the administrative password, the endpoints, and the size of the VM, they're all captured in the form of an ISO. And then we pass it on to the provisioning repository as an unattended file. And then we kickstart, we dissect this, and we understand what is there in the provisioning detail, and make a copy of the base image that you have asked for into your storage account. Create a lease so that you don't mess up with these disks that are in use. So we create a lease between the Windows Azure hypervisor and your storage account. So for instance, once you create your VM, you cannot simply delete it by going to a storage explorer, because there is a lease between the Windows Azure Fabric controller and the image that's disk sitting on your storage account. We create a cache VHD, and then we also create a OS VHD and the data file, and it's backed up against the Windows Azure storage. So this is what happens under the covers. Very straightforward. And the ISO is fed into this provisioning process in the form of Windows setup. So the unattended file processes this and gives the inputs that you've given in the provisioning process, such as a computer name and all these things as well. Very straightforward. And the ISO essentially is our primary mode for provisioning. This is an area where we hope to make a lot of expansions and extensibility as well. So currently, as you notice here, it's very limited to what you can specify for the virtual machine. You can envision scenarios such as providing a config file to start a particular role, giving an additional VHD in the form of an ISO for image customization. Let's say you want to run IBM WebSphere. How do I get that provision during the first provisioning itself? These are some of the areas that we will be expanding over time. Right now, it's very restricted to Windows setup. Over time, this is an area where we hope to expand as well. Once you complete, what are the things that you provide as part of the provisioning? First, your friendly computer name. Windows Update, by default, we turn it on all these machines. So, because inside the VM, it is your responsibility to keep the VM up to date, we basically turn it on. In order to domain join, it can be only done through PowerShell scripts right now. Let's say you want to create a SharePoint form on Windows Azure. In order to DC promote this, and in order to make it as a domain controller, you can only do today through PowerShell. Certificate and SSH or additional things that we accept in the provisioning process as well for authentication. So for example, the create server API already accepts a cert, so you can inject it. So for instance, if you're running an agent for monitoring and other capabilities, the monitoring agent can get authenticated using this certificate. Networking, by default, we configure the TCP and UDP ports, all the subnets and virtual networks. And obviously, if you have data disks that needs to be mounted onto the virtual machines during the bootstrapping process, we bootstrap that as well. This is what goes under the covers in the provisioning. All right, so once you set up your VM, how does it look? I wanted to call out a few hidden things that are happening right now without your knowledge. When you do a quick create or when you do a new virtual machine through using the gallery, by default we create a container for the virtual machine, and we call it loosely as cloud service. Please don't get confused with web role, worker role, cloud service. It is essentially a container. Our vision is to enable you to run cloud services, web, worker, and virtual machines as part of the same deployment. But today, we don't support that. The cloud service that we create, you can only see that when you go to the portal, that there is a cloud service behind a virtual machine. It is only a container today. But long term, you can also deploy web, worker, and virtual machine under it. So let's take a look at here. First thing I wanted to show you here is that there is a load balanced virtual IP for you. And then this is a container I was talking about, the cloud service. Then the second thing is, within the container, you can have multiple deployments, and they all have the DIP address here. So you have port forwarding for multiple virtual machines. So basically, within a container, you can have multiple virtual machines. So you can, if you wanted to reach out to a particular port on a VM, you have port forwarding mechanism that I will go through that shortly. And all these VMs are backed up against your storage account. So this is a high-level topology of how a VM shows when it's provisioned in the using the portal or using the PowerShell. Couple of points I wanted to call out. I made some of these slides based on the feedback given in the Windows Azure forum. Customers are finding it very hard to understand the portal sometimes is not giving you the accurate status of the virtual machine. How do I know it? So essentially, let's take a look at it. When you do a REST call of get deployment, there is a REST API to get deployment, and you can pass the cloud service name, the container name. You get, this is what you get. Under the hood, you get your role name. Unfortunately, we use some terminologies that's not super useful here. Role is essentially the old cloud services concept. You will see a role name called your VM name. The subnet instance status is the one that really illustrates what status your virtual machine is right now. It could be in a stop status. Sometimes during the provisioning process, it can get into an unknown status for a brief time. So make sure it is in a ready role in order for you to do an RDP or ping. IP address is your virtual IP address, and it shows all the port forwarded input endpoints as well. These are your external endpoints that are mapped to an internal port. In this particular case, RDP, remote desktop protocol is automatically enabled when you do a provisioning, but others you have to manually do that as part of your provisioning. As you notice here, a few things. Sometimes you might be wondering, where is my VHD file? Where is it located? It's very hard to find it sometimes. The media link is the attribute or element that clearly identifies where the VHD file is located. So when you're looking for that, that's the keyword you should be looking for. And obviously, similarly, the data disk location is another thing. The media link for the data disk will be there as well. All right, a few things about how to manage your VM. As I mentioned, remote desktop is configured. When you land in a VM, it'll be configured. You can RDP seamlessly. Windows Update is turned on. However, if you have multiple virtual machines as part of your workload, we don't do a coordinated Windows Update. It is your responsibility to enable that. So if you're wondering about availability of your application, that's something super critical for you to coordinate. The next thing is, how do I acquire my software? As I said, the vanilla VM doesn't have anything. You need to light up roles in it. If you need to install software, you need to use it. You install it through a bunch of tools. One of the most popular ones that I keep recommending everyone to quickly install your base software in it, particularly for a Microsoft stack, is using the Web Platform Installer. So that also does a dependency check and brings all the things for you seamlessly. Then you can also bring a data disk. Let's say you have a WebSphere license and you have to bring it from on-premise. That's how you bring it. Or you can create a virtual network and connect to on-premise, or build an FTP server, connect to your FTP network, and install all your software. All right. Some of the product, yes. 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 It is a stable version. The question is there a command line version of WebPI, Web Platform Installer? There is one. It is quite stable. One of our aspiration is also give you the extensibility hook and tell during the provisioning what softwares you want to install in the VM when you land. We are looking at Web Platform command line as well as a means to acquire Microsoft stack, server stack. Yes, today we don't support that in the provisioning process. You have to RDP into the box, run command line, WebPI command line, or the silent install, which will seamlessly install everything without manual intervention. All right, so when it comes to protocols, many of you might know that we support UDP right now. So if you have a low latency VoIP or scenarios that involves low latency scenarios like a gaming application, UDP is great way to do that. We support it in IaaS as well as in web and worker role as well. So if you're building a comprehensive VoIP solution or a low latency over UDP, absolutely this is supported now. Any traffic, once you create a container cloud service and multiple virtual machines underneath the container, the traffic between VMs is wide open. We support, by default, it's wide open. We support UDP, TCP, and all the protocols, and the communication is wide open there. We also have load balanced custom probes as well to monitor the health of your web app. So it's very easy to set up. And obviously, as I mentioned earlier, if you have multiple VMs, the way you choreograph your ports is using by creating the port forwarded external endpoint. We call it as input endpoint. So you will have multiple input endpoints for your cloud service that will correspond to different ports running in the virtual machines. Now, switching gears, more friendly for developers, I wanted to tell you, all you see today is completely is open. It's exposed. The virtual machine capabilities, they're all exposed in an open format, REST over HTTP. What we essentially did, if you're familiar with Windows Azure Service Management API, we have expanded the footprint to support the concepts of images, virtual machines, disks, and all these primitives as well. And very shortly, when you see our partner Scale Extremes demo, it's all built using the open protocols that we have. So you'll see that. So it's completely open. You can build a rich portal experience just like the Windows Azure Management Portal. Windows Azure Management Portal is also using the public REST. So so you can pretty much build all the capabilities of the portal on your own as well. This is very important to remember and internalize, because if you have a large workloads on-premise systems that needs to be extended to do a large deployments, you can seamlessly do that over the REST APIs. And pretty much for all the VM operations, we have REST APIs. You can create a server, get status of a server, modify the server. Please, I apologize for the fact that we have some contradictory, confusing terminologies like roles. We come from a platform as a service background for web and worker roles, so we are still using some of these. Over time. We'll have better symmetry and clarity. So essentially here, role means a virtual machine here. If you want to get VM details, if you wanted to stop a VM, you can do that. You can shut down and stop a virtual machine, and also you can capture the VM over the REST, and download the RDP file if you wanted to connect from. There's another way. A lot of times you may want to, if you want to troubleshoot a particular VM, you can download the RDP file and give it to one of your colleague for debugging or diagnosing. So those scenarios are fully supported as well. The only primitive we support for virtual machines today is essentially knowing your VNet configuration. We have a very only API for that today, but this is an area where we will be expanding to give you more knobs around virtual machines. Currently, you can only set the network configuration file get and set, but over time, you can envision creating your virtual network using REST APIs as well. Just a couple of samples. How do I do a HTTP post to create a new VM? All the provisioning parameters are sent over here over REST here. Very straightforward. Similarly, if you're giving a friendly name here, as you notice here, once the machine is captured, this is a target image name is the target image name, the friendly name that you give after you do customization of a SQL image. We also recognize many of developers want speed dial in the form of client libraries. This is an area where we will be investing heavily over this year. So you should see client libraries in .NET, Java, and PHP. Currently, the PowerShell uses the .NET client library. It's open sourced in GitHub. You can download it, take a look at it. But we recognize that many of you will have mixed workloads, so we'll have Java and PHP as well in the near future. Again, at last week, we also announced a PowerShell commandlets for operations over REST. Again, PowerShell is a great way to automate virtual machines on Windows Azure. Many things that the portal doesn't support are fully supported. Particularly the things that I wanted to highlight are really IT Pro specific capabilities. Repeatable multi-VM authoring scenarios. If you are creating a SharePoint form in a dev, test, production environments involving test servers, doing it over portal will take you nearly 3 hours to complete the whole thing. In PowerShell, not only you can have a repeatable template, you can save this template, repeat it in different environments, in different subscriptions as well. So very seamless. I'll give you some demonstrations shortly as well. Again, it's super straightforward. We use the Windows Server PowerShell syntax and scenarios and patterns and practices as well. In fact, we are constantly being pinged by the PowerShell team to say, hey, this is not the way we like to manage Windows Server, so change your PowerShell syntax this way. So they are in our review board, and we will continue to optimize and improve it and make it closely with the Windows Server PowerShell capabilities. All right, so now I'll switch gears. I'll show you 3 things here. First, I'll start with REST, and I'll show you how open it is. Then I'll move into PowerShell commandlets. If you have a lot of IT optimization as well as deployment that needs to be captured in commandlets, I will show that. There's one thing that I haven't called out in my slide that I will go deeply, which is essentially a cross-platform commandlet tools written in Node.js. That is another thing that we are shipping as well. This allows you to manage virtual machines from Linux and Mac as well. So basically, if you are running in a Linux or Mac, you have a commandlet that you can download. I'll show you how that works to manage your Linux VMs as well. Then I'll show you how to build multi-VM scenarios using PowerShell very easily. So let's take a look. The first one, I'll start with REST here. So this is essentially a simple client tool written over .NET. Basically, it's a .NET client on top of our REST stack. As you notice here, I'm using my subscription ID against management.core.windows.net. This is the public REST endpoint for all our REST APIs. As you see here, my primary goal is to show you that it is open. You can this piece of software we plan to distribute it as a utility as well eventually. So as you see here, this is my subscription at a highest level. I get to see what comes out from my subscription level. Let's do list hosted service here. This is essentially list of all the containers for your virtual machines. This call, wow, I seem to have some network issue. Hopefully this comes back. So basically, good. It did work. So basically, it's basically this call is a HTTP GET, and it's bringing all the cloud services I have under my subscription. As you see here, I should have a plenty here. Let's take one of them here and then see what is behind it. This is an app VM feed. This is a container here. It has a deployment already. Let's see what is behind this one. And I wanted to go to the VM level payload coming from the REST. So hopefully this should return the virtual machine behind it. So as you notice here, this virtual machine is ready. It's running nice and fine, and this is a public virtual IP address of this, and it has one RDP port enabled. And the power state is another thing that you might want to know. The power state of the virtual machine, it is already started. And in case you're wondering in case you're wondering whether this is a highly available system, it's unfortunately not. It's a single instant virtual machine. That means you get 99.9% SLA. And then you also get to see all the VHD details, the media link I showed you earlier. Where is it persisted? What is the disk name behind it? What is the hosting cache value, whether it's read, write, or read? The virtual machine size. From here, you can make operations, you can change it, you can add an endpoint, and all these things. Just to quickly show you the tip of the iceberg in terms of this is open, it's all REST over HTTP. You can do that from your favorite tool of choice as well. The second thing I would like to show you is switch gears into PowerShell. So what I wanted to show you is how easy it is to do authoring over PowerShell here. So let me go to this one here. I'll make sure this is the right subscription. Essentially, what I wanted to show you is bunch of PowerShell commands. First, list all the images supported by Windows Azure. So you can see here, these are the base stock images that Microsoft supports today. As you notice here, WebVM is the one that I've captured and created as part of my image customization added to my playlist. So notice that it is also showing up in the platform image gallery. What I wanted to do here is essentially have a bunch of repeatable scenarios. So I thought a couple of things I would like to show here are essentially I want to create a large web form using the same stock image of WebVM that I have already created. This has the whole Microsoft web stack in it. And then I want this to get the basic provisioning configuration and the endpoints. And also I want that to be load balanced as well as by a load balanced endpoint. Very straightforward. And not only that, I want that to be managed collectively in the same cloud service, same container. These things, so you can imagine having a large form where you need to have multiple virtual machines part of a same network. So that's what I am trying to do. Essentially, I want to call it WebVM 7 and WebVM 8 as the name of this VM. And then I can seamlessly author this simple command in PowerShell that will create virtual machines under this web form Europe, which I already have in the portal. Let's go back here. So this is the, if you look at the container, the web form Europe is the container for a bunch of the virtual machines I have, the web VM1, VM2, and all these things. This is essentially my web stack where I wanted to run a large web application. So let's go ahead and run this and see what happens. So it should hopefully get started and create my virtual machines. So it's doing virtual machine 7. Very shortly, it'll move on to VM7, bypassing all the provisioning details and add it to a load balanced endpoint as well. So while this is running, I'll switch gears to another commandlet tool, which is what I called as the cross-platform Node.js based commandlets tool. You can download it. It is also in GitHub. You can download it from windowsazure.com/manage as well. So this is essentially is also super straightforward. Let's do a few things here for the let's do a few things here. So first thing I wanted to do is essentially similar commands. Tell me all the data centers that Windows Azure supports. Essentially, once you install this and import your published profile setting, or rather your certificate, it's very easy to run any commands. It's essentially Azure VM location list. That lists all the data centers that we support. Then I wanted to show a couple of things, such as, okay, what are the images that you support today? So this command is essentially Azure VM. This is essentially, sorry. This essentially is a command to list all the VMs, and I can then say Azure VM this will list all my virtual machines under my subscription that are running. Hopefully this should be about 9 or 10, and including the one that we have just provisioned. As you notice here, Web Form 7 is still being provisioned, so it's not showing up yet, that we just created using this. This commandlet is super easy also to make changes to your existing VMs as well. One of the things that I would like to show you here as we are doing this is essentially, I went through the Windows Azure Management Portal and created a Linux VM here. When you create a Linux-based virtual machines using the platform gallery, it automatically configures port 22 for you to do SSH. So, however, the web traffic is not enabled here. So what I'm going to do is, instead of adding an endpoint from here and opening a port forwarded endpoint, I'm going to do that using the node.js tool. So let's copy paste the simple command. So it's essentially all we need to do is essentially So what I'm trying to do is essentially, I'm doing creating a new endpoint for this Linux VM. I'm setting the public port as 80 and mapping it to an internal port as 80. Hopefully, this will create a input endpoint for this in order to accept web traffic on the machine. So while this is going, I'm going to quickly connect to. Let's close this one. Let's run putty here. So what I'm going to do is essentially take this configuration. Let me show you what I'm trying to do under the covers. Let's go back to the Linux VM. This is a URL of this Linux virtual machine. So I'm trying to SSH into this box right now over port 22. So you get all these details right in the management portal. So when you go back to the putty, you connect to that. Okay, let me give my password. All right, I'm here in the command shell. So let's see what happens to this endpoints right now that we ran from the node.js commandlets. It is still updating. We have multiple. So one thing I will tell you, okay, it's completed. One thing I will tell you is that sometimes there could be some lock when you're doing some operations. Sometimes there is a lock at a subscription level. So you need to be, if you're doing multiple jobs across different connections, sometimes it can lock your whole subscription also. In this particular case, number 7 is completed as part of the web form. And hopefully, if I go back to the portal right now, this endpoint that we added is showing up here as well. So now I could pretty much connect and install my favorite software. Let's go ahead and from the commandlets, I'm going to install Apache web server into this. Just a second. So all I'm trying to do is I'm trying to get Apache, and I will pass my administrative password. So it should download Apache and install it in a couple of seconds. All right, still doing it. Let's go ahead and take a look at the web form command. Yes, it's complete right now. So now VM 7 and 8 should be here as well with the base image of web, the stock image that we had created, and it should be load balanced as well. So if I go back to the endpoints, you notice that it is accepting traffic in the web port, and it's backed up by a load balancer. So this is an easy way. If you're creating a large web form, you can automate that using PowerShell. Let's go back to the Linux session here. I think it's complete. Good. So what I would like to show here is that I should be able to copy this Linux URL and go to port 80, and Apache should be running right now. There you go. So very straightforward to automate your workloads and virtual machines, both from PowerShell as well as from the node.js commandlets. The key point I wanted to leave you with is this commandlets, the node.js, can run on Mac and Linux. So if you're using only Mac, this is a primary way for you to automate large workloads on Windows Azure. All right, so I think with that, I'll go back to my slide. All right, so we've gone through all the commandlets, the REST APIs, just to give you a bird's eye view of what you can build on the Windows Azure platform. Now, at this point, I'm very, very happy to invite Karthik Ram from Scale Extreme. Scale Extreme is a cloud-based software company based out of Bay Area in United States, and we worked very closely during the development of infrastructure as a service. I want to leave you with Karthik's demonstration of how they have built their monitoring, management, and governance product and a platform on top of Windows Azure, and have augmented the gaps as well. So, Karthik.
Sure. Hey, thanks a lot, Vijay. Excellent overview of everything so far. So first of all, I wanted to start off by saying that we've, as much as with any external organization, we've worked extensively with the Windows Azure team. Getting access to the APIs has been amazing, and getting into understanding the product and having it instantly on right from the get-go has been fantastic.
It is already on. You're on there. Okay.
So just moving a little computers here. So just a brief overview of Scale Extreme. I'm Karthik Ram, by the way. I run engineering for Scale Extreme, and we've been in business for about 1.5 years. Our primary motto is systems management in the cloud. So we can pretty much manage any machine out in the internet or in the intranet from the cloud. We don't listen on any ports. So from a deployment perspective, our solution is an instant-on solution. All we require is an outbound connection somehow, if it's a proxy server, because some servers do not have access to the internet, we transparently handle all that. So, and our agent is a very low footprint agent, about maximum 7 megs depending on the operating system. We support Windows and Linux as first-class providers, and we offer pretty much an automation framework with monitoring and patch management. In addition to that, pretty much covers a lot of systems management for machines which are not VMs or not in the cloud. For things which are in the cloud, we start to see that costs are a big issue, so we offer budgeting and cost control as well, so that you can understand where your costs are going into, which VMs are costing more or less, who can access certain features, who can launch machines in certain clouds, things of that nature in certain regions in Azure. We provide that sort of a fully granular RBAC system-like control. And we've taken advantage of the service management API that Vijay mentioned extensively, and tried to solve some of the non-trivial cases that may be a little bit cumbersome with the existing tool set. So just a little plug here. If you wanted to sign up, it's pretty simple. You go to scaleextreme.com, free, and then you link your Azure account. All we need is your subscription published profile. You upload your published profile, and then your Azure account becomes visible to Scale Extreme. And from that point onwards, you can manage all your machines on Azure. And if you have machines which are not on Azure on-prem, you just install the agent, and the agent is configuration-free, so it automatically connects back, and we're able to manage the machines from there. Okay, so with that said, I'm just going to launch into a quick demo of what we can do. I think you've seen enough of launching machines in multiple forms, so I'm just going to fast forward to the point where once a machine is launched, what can you do, the life cycle of the machine, things of that nature. But I will also cover some of the non-trivial things that we've done for launching a machine. For instance, launching multiple machines into a web service. For instance, the farm case that Vijay mentioned, where you have to launch 10 machines into a single web service because they're all going to be load balanced and whatnot. And it's a serial operation, so we transparently handle things like that for you. Oops. All right. I'm just going to log out just for the purposes of demo and log back in. So we support multiple multiple organizations within a single account to cater to the MSP market and the VAR market. I'm going to pick an account which I've set up Azure on, which is a company. And within a particular company, I can have multiple roles. It's a full RBAC system whereby you can control and limit what you can offer for a particular end user. I'll show that in a minute. So in this case, I'm going to select admin because I want to show off everything. But you can be as restrictive as I don't want this particular person to go on this particular machine. We also support endpoint impersonation on the machine. So let's say, for instance, that you want Karthik to go as nobody or a guest on a particular Windows machine or a Linux machine, but Vijay to go as full administrator. We support that transparently. So we take advantage of whatever machines are on the endpoint, whatever users and credentials are on the endpoint, and we support full impersonation. So as you can see here, it's a little busy lot going on. We've been launching things and testing it out just before the demo. So this is our dashboard here. You see a bunch of machines registered, servers available. You get a bird's eye view of what's going on in here. We continue to evolve as time goes by. We just added our monitoring solution, so you'll probably start to see a lot more monitoring-based metrics come into this particular view. But this gives you a general idea of what's going on within your particular company, who's doing what machines are available, and things like that. I'll quickly jump in to show a bunch of machines which are launched, Azure, and how we kind of provide value there. So as you can see here, the primary user interface has this concept of a manage, where you can do ad hoc operations. These are all pretty much live operations you can perform on the web browser. It doesn't require any plugins of any sort. So for instance, I can jump on a Linux machine which is running on the Western European Center somewhere in Azure. And I can, if for instance I want to do some out-of-band operations, I can readily do an interactive top. All these are happening over a one-way HTTPS outbound connection. So we're not listening on any ports, anything of that sort. So as you can see, we understand VT100 and emulate the command shell for you. So some quick out-of-band operations, that can be it's readily doable. The other thing that we also do as part of launching the agent is we immediately understand what patches are available, what patches have to be applied across Windows and Linux. So for instance, this is an Ubuntu machine which has about 32 quote-unquote updates available, which is the Linux term for patches. And along the same lines on Windows, once it loads here, I could not connect. Well, I'm not sure why the machine is saying it could not connect, but in general, the idea is that you would be able to, if the machine is online and we're able to connect to it, you would be able to go into that particular machine and look at all the updates that are available and proceed to go ahead and patch them on a scheduled basis or whenever you want to do it. In addition to that, we also, if a particular patch is available on, let's say, 100 machines or so, we're able to find out what machines those are on. So in this particular case, the whatever patch is selected, app utils, was available. I selected with one, I went in with one, but immediately I found out there are multiple machines which also require the same patch level. This is very useful for somebody who's in the security business where they want to be able to update a critical patch across all their machines, across all clouds, whether it's physical, on-prem or off-prem, on the cloud. They want to be able to quickly do it. We facilitate that. The other cool thing that we've just added is the monitoring with alerting functionality. Again, it's instant on. We just announced it. It's an opt-in beta. So for those of you who are interested, we support up to 30-second intervals of monitoring and alerting. So it's pretty, not that everybody should go for that deep an interval, but we can support up to that level at scale. And we support a bunch of applications right now, starting with, and we detect what kind of a machine that is so that we show only the relevant applications that are supported. As you know, there's a laundry list of things that you can keep adding, and we will be adding, and we have a plugin architecture which is very easy to integrate and add your custom applications and things like that. So expect this particular list to grow, but monitoring or enabling monitoring for a particular stack, let's say it's on a machine, is as simple as just selecting a checkbox and it's instant on. There's no other configurations to do or anything of that sort to understand beyond what you see out here. It is possible to get into the command line and muck around with a lot of things, but that said, if you don't have to, you don't want to. And these are the alerts that are showing from yesterday. It's basically saying that there are no problems with anything right now, but it's just showing a general overview of what alerts are happening and things of that nature. With that said, very quickly I'll jump into the Azure cloud that I've linked to my account to show how we're using the REST API to suck the information from the Azure cloud, and how somebody who's having some existing machines on Azure, we can basically deploy our agent without even leaving this particular screen. So for instance, if I were to let's say I come in with all these machines are already managed by Scale Extreme because we launched it through this portal. But let's say I wanted to install the agent on all these machines. It's as simple as saying, I want to install the agent, and depending on how your configuration is with respect to, you have a common password or a common private key for all these machines, or however your user management is for the administrator of the particular machine, you could basically go ahead and plug it in. And we understand RDP as well as SSH, and we install the agent over RDP or SSH. And Azure provides a nice way to map out the ports, as Vijay mentioned, of the SSH and RDP. So we're able to programmatically understand, even if it's a high port number, it's not 22, but it's something else, we're able to go transparently and manage the machine. With that said, let me jump into one other quick overview of the launch instance where there are some non-trivial cases that I wanted to illustrate. So we're going from Europe to USA back to Europe. So okay. So the launch server, again, it's going to take a little bit of time to go and pull up all the images and storage accounts under my account. But in general, all the machines that are available in the portal, all the images that are available through the portal, as well as through any custom images that Vijay mentioned that you could upload through a tool like CS Upload into the portal, are available through this platform. So you can readily go ahead and launch any of those machines. We don't require anything pre-baked from our footprint perspective on those machines. So any images which are supported on the gallery, you can basically install them. So any of these machines, you can pretty much go and install. I don't seem to have any custom images, but if you have custom images, and as long as they're RPM-based machines or Debian-based machines in the case of Linux, or a standard Windows machine, any of these SQL Server VMs or Windows 2008 or Windows 2003 or 12, we can provision the machine as well as install the agent and do some other cool things. By some other cool things, a very quick segue, since we're kind of almost near running out of time. Let me show you a very brief example of what I mean by some other things. There are multiple strategies to how somebody would manage an image and how they manage their environment. People like to patch it and keep a gold image, master image up all the time. That works to a certain degree, but then let's say you want to do some more additional customizations, maybe deploy the code, maybe open certain ports, maybe open communication between a particular machine to another machine in the cluster, things of that nature. What we have this concept of steps. So what you could do is you could build an arbitrary workflow post-machine install that would enable you to do pretty much whatever you want in there. So I have some very quick examples of things here. So taking a case that Vijay just illustrated, whereby we were doing some Apache installation through the command line. You could probably do this a little bit more efficiently if you were to give access to multiple people and things like that, so that you don't have to let them give full access to the subscription ID and that sort of nature. All you ever want them to be able to do from a self-service perspective is to go here and just launch a template. Because you as an administrator have determined that this is the configuration that you want, this is the patched configuration that you want, and you've already set up the port forwards through the portal here. Whereby you've said that, hey, this is a web server. Oh, and by the way, I'm going to allow port 80 to be open, and this is the default password. None of those things, you don't have to communicate to your entire organization because people are just consumers at that particular point. So this becomes a very effective use case for doing something like that.
Fantastic. Thanks, Karthik. This is great to, I hope this gives you a tour of how ISVs like Scale Extreme are building great solutions, augmenting the gaps of Windows Azure platform, providing value. Thanks, Karthik. So I have a few topics. I hope you can stay for 5 more minutes. We can quickly cover. Let me switch my slides. So a few things. Availability. Single instance is backed by 99.9% SLA. And if you want to have 99.95, you need to create a container and create an availability set for it. So that's a concept I will be going over. What does it cover? Anything inside the VM is not covered under by our SLA. So if you are running some third-party software that's crashing, that won't be covered. What is included is essentially the host level upgrades, and if our hardware crashes, our SLA is included there. And if we update the host operating system on a periodic basis, those are all covered. So a couple of scenarios here for an. I hope my thing is this working. Oh, wow. All right. Anyway, so. The way you need to think about building a highly available system is essentially, create an availability set for the VMs that you have at every tier. So for instance, if you have a large multi-tier application, you need to have more than one VMs at every tier to have 99.95 availability. So essentially, this illustrates if you have a single SQL server, it's 99.9, and if you have a SQL replication and mirroring between 2 VMs, you will gain 99.95, and they need to be backed by the availability set soft concept. So this is a pattern to illustrate how to build highly available and build redundancy at every level in your application stack. This is a front-end middle tier. As you notice here, you have multiple virtual machines doing the similar task at every level, offering you highest availability. One thing I didn't cover deeply, I was going to do a demo, but I'll quickly illustrate here. Since many of you are Windows Server customers, I think I would like to strongly recommend you to also take advantage of group policies to automate many of the scenarios that are not supported out of the box, particularly Windows Server Update Service, automating that across your network. So one of the scenario that I would like you to leave you with is essentially, if you have a large enterprise application, one of the pattern to consider is to nominate one of your VM as a domain controller and manage the network of computers attached to the domain controller using group policy. So I have a demonstration here that I will quickly jump into where I can illustrate this in depth. Let me just switch gears a little bit here. Let's go back to the management portal here. What I'm going to do is I have a network of computers that is managed by a domain controller. What I did is I started this VM using a stock image, made customization, captured it, and then went to the command prompt. I enabled Active Directory services, DC promote this machine, and right now I'm basically remote desktoping into this. And every time when a new machine is being created, I was adding that machine to this domain control machine. So let me show you that in action. So when I launch into that, I have a single pane of glass to manage all the VMs as part of my application in a centralized way. So as you notice here, this is my server dashboard. You can see all the machines that are joined to this domain. The most important thing, however, is essentially I have enabled a bunch of services. Remember, I talked to you about how hard it is to customize your image. What I have enabled here is that as part of my group policy, I am distributing software installation into all the machines that are domain joined. So for instance, running SQL Server or patches. I've enabled Windows Server update service to all the machines that are domain joined. So by default, I can find out how healthy all the network is. How are the machines running? So I can quickly go and take a look at all of them right here. The last but not least is essentially I've also enabled remote PowerShell management. So I can navigate between machines that are domain joined and manage them in a centralized location. So this you can totally automate that. I have a script that illustrates. If I had the time, I would have shown you that. So essentially, this is essentially the domain join script to illustrate that there is a my demo DC, and I have created a domain controller here. Whenever a new virtual machine is added to the DC, they automatically inherit all the group policies applied at the domain controller, such as software installation, Windows Update service. So this way you can do a coordinated Windows update. You can do software installations, remote management, and all of them as well. This is another way to manage all these things. So I'll go back to my slides. I think we are at the end of the talk. So one thing that wasn't covered in any of the talks that I want you to leave you is basically we are in a journey here. The containers such as cloud services, the ability to stitch things together such as from web services to cloud service to virtual machines, this is all will get much easier in the future. We are a platform that gives you 3 hosting options. Whether you want to build a multi-tenanted websites, you can do that using websites. If you have a large web application that needs to be managed and multi-tenanted, multi-instance, you have cloud services. If you have existing workload that needs to be run on Windows Azure, you have virtual machines. So you can mix and match all of them together. You can connect them over the virtual IP. Over time, we will allow you to deploy all of them seamlessly into a single deployment as well. So you have complete power of choice when it comes to Windows Azure, stitching things together, virtual machines, cloud services, and websites. So I want you to take advantage of all these things. And if you have any questions, I'll be around. I think the next talk is going to start very shortly. Thank you for your attention early in the morning today. And by all means, give me all your feedback, and I'll be around to take any of your questions as well. Thank you.